Okay, engineering students, welcome back. Want to look at the final section on this naming uh, or identification of the structures of alkenes. In this case, you're going to be looking at two forms uh, because you're trying to look at an exam situation in which you can be given a normal structure containing the carbon and the hydrogen shown. Now in this case I want to show you that if you're given in this form, you can convert it into the bond line structure like the one which is shown on your right. Yeah? It's shown on your right. That this one here, this one here, a demonstration. Okay, this CH3 hydrogens are not normally shown. I mean, are not shown unless if they are attached to a heteroatom like oxygen, nitrogen, and the rest. Yeah, in that case, then you may need to actually show. But in these bond structures, they are not usually shown. So in this case, when you have such a case in which here there's a CH3, this assumes that because you are dealing with three bonds, then there has to be a carbon with a hydrogen here. Then this one is it's like a carbon with a CH3. A hydrogen is not shown, and then there's a CH3. So I want you to see in your mind. You can be given in this form to see how you can be able to convert to this structure. You can be given in this form, you can be able to convert to this structure. So the first two structures, they are given in the normal Lewis form, the complicated form. And then you need to convert it into the bond line structure. In an exam situation, most likely the structures are likely to be in this bond line structure, both for ease of visualization and also it saves time and space to have it in this. It's like a shorthand notation. Yeah. Now in this case, the last two examples are being shown like in the bond line structure, so you need to convert them into the complicated form. Yeah. So I hope you'll be able to see this. Now coming to an end, what we want to do is to see how we can name these four structures. So the first one, I'm going to put the word A, the second one is B, the third one is C, and then the fourth one is D. Structure A, B, C, and D. Okay? So by the look of it, you can see these are alkenes. So it means that the name is going to end with ENE. Okay, there's something which I need to mention, and before I name this one, and I think I should have put it earlier. For example, if I've got something like the one which I've shown earlier, I'm going to delete. Okay, so for example, okay, let me still have it like that one. So I said the double bond is between carbon number 2 and 3. Yeah. So this one, it will be called 2-butene. Now, what you're going to see is that, like in the cases which I've shown here, most of the time the alkenes may have a substituent, and if you're going to have a number showing the double bond before, when you're going to have a substituent, for example, if I had something like a methyl group here, you can imagine having maybe I say position 1 and 2, 3 and 4, so that this one will be something like maybe, okay, let me say 2-methyl, and then I put 2-butene. Yeah. What you're saying is that this alkene is a 2-butene, and then there is a methyl group on carbon number 2, which means that you are numbering in such a way as to give the double bond the lowest number, assuming whichever direction you take, you come to the same number that the double bond is on carbon number 2. So it means that you need to give the lowest number for the substituent. But now a number like this one may be able to interfere with the position. So what the scientists have done is, for the position of the double bond, you can move it inside before the position of the double bond, before the E and E, so that this one can be also be called 2-methyl, and then you put but, and then before the E you put the number 2, and then you put the word E and E. Can you see this one is much easier to read, and everything is a bit clear as opposed to in this case where there's a number for the double bond outside and the rest, yeah? So this is the most preferred way of naming alkenes when they contain substituents, and this is the form which I'm going to use, yeah? So I want you to spend some time. I want you to look at that one, because I'm going to delete it, because I want to name these other alkenes, and there may not be space on this whiteboard to name those alkenes, yeah? So there is this, it's got a CH3 carbon hydrogen. Oh, by the way, now in this case, okay, I wanted to have one in which the osteochemistry, but in this case, because you've got two similar groups, you cannot put E and the Z, yeah? You understand why I'm not putting E and the Z, because you've got two similar groups on one side. But if you had something like the hydrogen, yeah? Hydrogen like that, yeah? Then it should have been what? It should have been Z but2-ene, yeah? Without the methyl group, without that one. But now, because I've got two methyl groups, then the stoichiochemistry like the E and the Z disappears, yeah? Okay? So what I'm going to do is that I'm going to delete this, and then we try to name the others. I think you've been able to put that one, and you can be able to zoom in on the video to be able to see these sections, yeah? So I'm going to delete it in a short while, and then you can proceed from there. Okay? It was just an explanation, but this is what we are having on the board, yeah? All right. So let's look at structure A, yeah? So the rules indicate that irrespective of the substituent, you need to look at you need to number from the position, from the side of the alkene that will give the double bond the lowest number. So in this case, I'll have to start from this side. 1, 2, 3. Now, these are substituents, so this is number 4 and number 5. So this is an alkene containing 5 carbon atoms, so it is a pentene. And then the double bond is on carbon number 2. And then what are you seeing? There is a methyl group on carbon number 3. There's a double bond, a methyl group on carbon number 3. Now, is there stoichiochemistry or regiochemistry, either E or the Z? The answer is yes. So let us see. On this side, this has got a high priority CH3 compared to the hydrogen. On this other side, there's the CH3, it has got a low priority compared to the ethyl group. So you've got a high priority group and a high priority group on opposite sides. So you're going to have what? E alkene, yeah? So you're going to put E at the front there. Then as you mentioned, there is a methyl group on carbon number 3. So I'm going to put 3-methyl. There's a methyl on carbon number 3, and then you put a dash. So this alkene has got 5 carbon atoms, so it is a pentene. And so you're going to put the name pentene, but just before the name E for the alkene, you're going to put the number 5 the number 2, indicating that the double bond is on carbon number 2. So I'm going to put pent, and then put a dash, and then you say the double bond is on carbon number 2, and then you put the word E. In other words, if I'm going to remove these two, if I'm going to put my hand over here, this will be a pentene. Yeah, it will be a pentene. It's a pentene, but you're saying that the double bond is on carbon number 2. So this is the full name. There is the E in bracket, indicating the radiochemistry. Then there is the where the substituent is 3-methyl, the methyl on carbon number 3. Then the name of the alkene. So let us look at the second structure. Let's look at the second structure. Aha. Now, 1, 2, 3, 4, 5. 1, 2, 3, 4. Whichever way you look at it. So in this case, the longest carbon chain has got 5 carbon atoms as well. But this side from your right, you get to the double bond faster. So you're going to number from here. 1, 2, 3, 4, and then indicate whatever position 5, yeah? So once you do that, and you're going to see you've got a methyl group on carbon number 3 and on carbon number 4. Yeah? Carbon number 3 and carbon number 4. And then, is there stoichiochemistry? The thing is yes. So between at this position, this is high priority, low priority. A methyl group is low priority, this is high priority. So you've got 2 high priority groups on one side. So that is what? That is Z. I'm going to put the word Z in bracket. And then we start putting the substituents. So the substituent which you are seeing there, there's a methyl group on carbon number 3 and another on carbon number 4. Both of them are methyl group. So I'm going to use the word dimethyl. And then I'm going to put some numbers indicating that the position at which the methyl group are indicated. So you're going to say there's a methyl group on carbon number 3, and then I put a comma, and another methyl group on carbon number 4, and then now I'm now through with the substituent. So I'm going to put a dash, and then I put, usually if it is the first letter, usually put it capital. So in this case, I'm going to put dimethyl, yeah? And then I put a dash, and then I now complete the name. Once again, it is similar to that one. It is pent. It's a pentene, but the double bond is on carbon number 2 in. Are we together? Z 3 4 dimethyl. Methyl 2 methyl groups on carbon. One is on carbon number 3, the other is carbon number 4, and it is a pentene. Have you seen that? You can have this illustration and also this illustration. Yeah. So let us look at the other two. Yeah. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So in this case, move from this side, you'll give the double bond the lowest number. This is the shortest. So the longest carbon chain is from here. 1, 2, 3, 4, 5, 6, 7, and 8. Have you seen that? It's also similar to this one. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So it's an octene. It's an octene with a double bond on carbon number 3. So it's like a oct 3 in. Oct 3 in. Okay. So there's a substituent, also a methyl group on carbon number 3 and on carbon number 4. Yeah? 1, 2, 3, 4, 5, 6, 7, 8. So once again, before you do that one, you need to look at the whether there is stoichiochemistry. And the answer is yes, you've got different groups. The first one is high priority, low priority. And looking at this other side, low priority, high priority. So you've got 2 high priority group on one side. So I'm going to put the word Z. I'm going to put Z, and then I say, and then you go to the substituent. How many substituents? I've got 2 methyl groups. So I'm going to put the methyl groups on carbon number 3 and carbon number 4, and then I put dimethyl, and then I put a dash, and then I say the name of the alkene is oct. It's supposed to be octane, but it has a double bond on carbon number 3. So I'm going to put 3, and then I put what? ENE. So it is an octane, but it has a double bond on carbon number 3. So have you seen how coming up with names is easier? It may be a bit complicated for a start, but you'll find out that it's quite easy to name that one. Then let's look at the last one, yeah? Let's look at what? The last structure. Wow. Okay. Perhaps we can number it from here. We see that the double bond is on the carbon number 1. So in this case, I'm going to number it 1, 2, 3, 4. Once I reach there, I need to look, hey, which side do I go to the longest carbon chain? Do I come here 5 and 6? No, that will be an isopropyl group, yeah. But we say that according to the rules, you're supposed to maximize on the substituent. So if I come 5 and 6 here, then I'll get a methyl group and an ethyl group as substituent, and that is allowed. Yeah. So 1, 2, 3, 4, 5, 6. So that will give a methyl group and an ethyl group as substituent, as opposed to an isopropyl substituent. So is there stoichiochemistry? The answer is no. There are two similar groups at the end, so there is no E or Z. So what I'm going to do is that I'm going to see that I've got an ethyl group on carbon number 4 and an ethyl group on carbon number 5. So I'm going to put, okay. So which one do you put first? E for the ethyl comes first alphabetically and then M. Yeah? So I'm going to put 4 dash ethyl and then a dash, and then I've got a 5 methyl and then a dash, and then it's a what? It is a hexene, and then it's a hexene with a double bond on carbon number 1. So I'm going to put hex 1 in. And have you seen there is no stoichiochemistry? So it is 4 ethyl, 5 methyl, hex 1 in. Very simple. So with that, I think we've done a lot on the alkenes. You'll be able to look at the rest of the notes whereby they contain the properties and also the uses of alkenes. What you're going to say, alkenes are the raw materials for what you're going to be calling polymers in the industry. So you're going to see in the uses, you're going to see that alkenes are used as the raw material. For example, ethene is used for making polythene. You're going to see, I think for now that is the most common alkene that you're going to be dealing with. You're going to see that alkenes are also known, but this one you're going to see in the reference books, that alkenes are also known by some of their older names. For example, you're going to see ethene used to be called ethylene, and something like propene used to be called, or is still called propylene. So you're going to see that that the polymer from propene is called propene or polypropylene as it's called, yeah. So, but that one you're going to see it under polymers. But for now, I think these 4 examples have just illustrated how simple you can just name alkenes. And as I mentioned, in these 4 examples, I've just taken the simple case of just showing the substituent, I mean alkenes, just which contain which contain alkyl groups as the substituent, yeah. But later you're going to see organic compounds, whether they may be alkenes or any other which you're going to get may have other functional groups, and the naming may be a bit complicated, but we'll come to rules at the end. Once you've dealt with carboxylic acids, then you'll come to see, hey, the compounds that you get in reality may contain this function group, they may contain an alkyl group, they may contain an alkene, an alcohol, an alkyl, it may contain a halogen and the rest. So we're going to see what happens, how you can name organic compounds with many functional groups at the end. Once you've known how to name each of the functional group with just simple substituents, yeah. So I believe you've really enjoyed this section on the alkene, yeah. Very simple. From the structure, whereby we had what? the alkene containing what? The double bond, and it's flat, and the bond angles are 120 degrees. Yeah. Now this is an example of an alkene with 4 different functional groups. So in this case, you'll have to name it with 4 different what do you call it? Like atoms, or they can be groups. In this case, we are going to use E and the Z as opposed to the alkene, which had 2 hydrogens, to which you had to use the cis and the trans. Yeah. So I believe you really enjoyed this section on alkene. So later we're going to be looking at the benzene compound. Yeah, we're going to look at it later. We're talking about, we'll be looking at the alkene containing 3 double bonds, and 3 double bonds and 3 single bonds in a ring. We're going to look at that one later, but that one we're not going to spend a lot of time on the like the one which you spent on the alkenes. But the naming, once again, it will be straightforward. So I really hope you really enjoyed. Thank you very much. Okay.